In development economics, we use a very famous index to assess the income inequality in a population, which is known as the Gini Index. It is based upon the Lorenz Curve. So we will recall the Lorenz Curve here, and this study of the Lorenz Curve basically allows the economists to measure the income inequality. It's a graph and it can be represented with this notation, that is L as a function of x. L stands for Lorenz, who gave this curve idea, and x is the independent variable in this case. As you can see in this graph, we have on x-axis the fraction of the wage earners. We are assuming that we are not dealing with the whole population. In this case, we can deal with certain segments of a certain profession, and we can see that how much of income inequality lies between that certain profession among the people who are in that profession. For example, we can judge the income inequality among the dentists, or we can judge the income inequality among the contractors simply by using such sort of graph, which is known as the Lorenz curve. So this is the fraction of the wage earners, 10% and 10% and so on. In this way we can divide and make groups of these wage earners, and then we can see that how much of the income is possessed by which of the individual. On the y-axis we have fraction of the total income, that is the first 10% of the income, then 10%, or the out of the 100 people, the first 10 people, and then the next chunk of the 10 people. They are visible on x-axis, whereas here on y-axis the first 10% of the total income and then the next 10% of the total income. In this way we have a kind of scale which is comparable on x and y axis. Now if I assume that this is the Lorenz curve, this straight line, then in this case if I assume that we are talking about the first 10% of the wage earners, it will give me this much of the earning. So this means that they have a certain proportion of the income, which is 10%. And if we talk about the next 10%, they will also have the next 10% of the total income. And in the same way you can see, because it's a straight line and it is making an angle of 45 degrees, which is known as the divider line. This divider line is going to give us the equal amount of income for all the individuals in the society or in this set of profession. So this is an ideal situation that every 10% of the people have 10% of the total income. So there is perfect equality, and this is known as the complete equality line as well, which here is equal to y is equal to x. It means that the number of the fraction of the wage earner is equal to the fraction of the total income. So that's a perfect situation that 10% of the people have 10% of the total income. However, in real life it does not happen, because we can see that perfect equality is more of a theoretical concept than the real life concept. Now we are revising the diagram. Let's assume that the first 10% are here, that is here. They get this much of the income, which is quite less as compared to the overall 10%. And this is because we are considering this Lorenz curve, which is represented with this symbol. And if we consider the next equal portion of the population, they will get this much of the income, which is again a smaller fraction than the 10%. Now these are the initial segments of the wage earners, or the population of the wage earners. However, if we choose this segment, which is the last segment on the x-axis, these individuals, let us see how much of the total income they get. You can see that this much of the total income they are getting. It means that they are in a kind of situation where they are having higher incomes than the other people who are having just small chunks of the population. These are of the income. These are the people lying here somewhere. So this shows that there is quite a bit of income inequality among the wage earners that we have. So let's try to do this quantitatively by using integration. So we have now R1 as one of the area and R2 as another area within this diagram that we will see in an elaborated way ahead. Right now what we have gathered is that complete equality line is y is equal to x, and it happens over this range, that is 0 till 1. You can see that the range is 0 till 1, and it is a measure of the income inequality in the distribution of wealth in a society. So the income inequality can be measured on the scale of 0 till 1. Now these areas will be visible in this panel diagram. In the first panel you can see that R1 is the area which is highlighted. It is the area under the perfect or complete equality line between 0 and 1, and the other line between which this area is highlighted is the other Lorenz curve that we have. So between this complete equality line and this Lorenz curve we have this area R1, and the other area is R2, which is relevant, and it is the area below this line, the complete equality line, between 0 and 1, and this area is now shaded. What we want to find out is the ratio of these two areas, that is R1 and R2. So the area R1 and area R2, they are to be calculated as we are guided here. The area between the two lines and the area below the complete equality line between 0 and 1. So this can be translated into integrals. Let us see how. This is the ratio, and this ratio is known as the Gini Index that we talked about. The Gini Index is also called as the index of income inequality because it tells us about income inequality. So GI is that ratio between R1. R1 is basically area between the Lorenz curve and the complete equality line. As you can see here, this is the area R1, and area AR2 is basically area under the complete equality line over the range 0 till 1. Now both of these can be plotted, converted into integrals. The value in the numerator is basically the difference of the two, that is the complete equality line and the Lorenz curve. We have written the difference of the two and taken the integral between the upper and the lower limit, that is 0 and 1. So once we did this, the other thing is the value in the denominator, the area R1, simply below the complete equality line, the shaded area or the area that spans from 0 till 1. So what we have seen in the diagram is now mathematized in the form of integrals. In the numerator we can keep it like this, and in the denominator we can easily solve because there is no functional form which was there in the numerator. So this is a certain value, that is x, integration of which is x square over 2. The limits can be applied. In the next step you can see the limits, they are being applied. Whereas the difference between the two curves, the area between them is kept as it is. When we further solve it, we get this answer, which is now written here as the formula of the Gini Index. Now we can do an economic application of this formula that we just developed. The numerical example deals with a governmental agency that determines the Lorenz curve for the distribution of income for dentists and contractors. So these are those Lorenz curves that is the governmental agency have determined, and now we can use these two Lorenz curves to find out if the dentists have more income inequality or the contractors. So how much they are having the fair distribution of income is what we will see in this economic application. So for that we can calculate the Gini index. So we calculated the Gini index for dentists and the contractors. Let us see how we did this. We are given the first Lorenz curve and the second Lorenz curve. The first Lorenz curve deals with the dentists and the second Lorenz curve deals with the contractors. This is the Gini index for dentists, and in this we know that the formula will be used as it was there, but that was a general notation. Now it is the Lorenz curve of the dentist. So therefore we put the value which was given in the given statement of the Lorenz curve of the dentist. Now the remaining thing is the simple algebra, which is done after the integration. So after putting these values, we will get a certain value for the Gini index of the dentist. It is 0.2593, and now we can do the calculation for the contractors Gini index by using the same formula. However, here the Lorenz curve for the contractors, it is used, and we have substituted the value. There are two values containing x in it after opening the bracket, so we combine these two values doing the simple algebra, and so these two values, they are combined and they become 0.8x. Then we can solve this by bringing out 0.8 as a common factor, which gets multiplied with the 2 which is there of the formula, and now we can do this integration, which is something that we have been doing before. Doing this integration will allow us to have this expression. Then here we are introducing those limits, the upper and the lower limits, and finally we will get the answer of the Gini coefficient for the contractors. Now it is easy for us to compare the two Gini coefficients. The Gini coefficient of the dentist was 0.2593. However, the Gini index for the contractors is 0.2667. It shows that the Gini index for dentists is lesser than Gini index for contractors, and that shows that the income inequality is higher among the contractors as compared to the dentists. A real life reasoning could be that the dentists, they are all having similar sort of education and similar sort of experience and avenues to earn, whereas when it comes to the contractors, they can have a variety of opportunities. Some contractors they get large contracts, some can be without any contract for some time period, or some might be able to find small contracts, due to which there will be quite a bit of disparity among all the contractors that are there in a certain population of contractors, and definitely the Gini index can be high. Here we can see it is slightly high, but definitely it means that the contractors, they have more income disparity because of their diversity and difference in the opportunities, as compared to those who are dentists, who are having similar sort of education and similar sort of earning opportunities. And in this way we have done an economic application of Gini index. Instead of applying it on macroeconomic level, we have chosen two segments of the labor force, and we also derived the formula of the Gini index by using our knowledge of integration, that is the definite integrals. And this was the topic, which was an economic application of integrals. Thank you.